All right, welcome back for example 4. So we're dealing with some linear systems of linear inequalities applications. So what it says is in 1 week, Ed can mow at most 9 times and rake at most 7 times. He charges $20 for mowing and $10 for raking. He needs to make more than $125 in 1 week. Show and describe all the possible combinations of mowing and raking that Ed can do to meet his goal. And then list 2 possible combinations. And this is just a table that just describes his earnings per job. So per mowing job, he gets $20, and per raking job, he gets $10. So the first step we have to do is write a system of inequalities. To do that, first we have to define our variables. So what are the things that we don't know, right? There's a lot of information, a ton of information. But the thing that we don't know is we don't know how many mowing jobs Ed is going to get, and we don't know how many raking jobs. So those are going to be our variables. So let's go ahead and say let X equal the number of mowing jobs and Y equal the number of raking jobs. Okay, perfect. Okay, now it's time to write our inequalities. Now there's so much information, it's crazy in this problem. So let's start with the first part. So it says Ed can mow at most 9 times. So he can mow at most 9 times. That's an inequality. How would we write that? Well, what is mowing? The mowing, is the X, right? So, okay, we can do this, no problem. At most 9 times. So it's going to be X and 9, right? Because X is dealing with mowing, and the number 9, and at most. So that means that X has to be smaller than 9, because 9 is like the biggest it can be. So X has to be less because 9, it's at most. But at the most is 9, which means it can equal 9, right? So there we go. There's our first one. Okay, let's keep reading. And then what does it say? So in 1 week, Ed could mow at most 9 times and rake at most 7 times. That's another one. That's another inequality. Okay, so raking is dealing with Y, right? So we're going to use Y, and at most 7 times, so we have 7, and it's kind of like the same thing, like at most 7 times, so that means he can't rake any more, so Y would have to be less than 7, but at most 7 means that it could be 7, so that means it can equal 7. So, oh my goodness, we already have 2 inequalities, but you know what? There's all this talking about like money and making money. That is another inequality. Oh my goodness, we are going to have 3 inequalities in this system. This is going to get out of control. I can't believe it. Okay, so what's the other information? He charges $20 for mowing and $10 for raking. Okay, so this is all about making money. He needs to make more than $125 in 1 week. Okie doke. So he needs to make more than 125, and the 125 is made up of the mowing jobs and the raking jobs like added together, right? So to write this inequality, that's going to be 20 with the mowing jobs, which we don't know, which is X, right? So we're going to go 20X plus, because he makes $20 per mowing job. And then we're going to add the $10 per rake job, which would be Y. And then we have 125, right? And so he needs to make more than 125. more than. It's definitely more than. So this amount is the money, right? This is of the, what is this? The rake jobs and the mowing jobs. So all of this needs to be bigger than 125. So that means, and it didn't say like, you know, it was nothing about like equaling 125. It was definitely more than 125. So there you go. There's our system of inequalities. There's 3 of them. This is so exciting. We haven't done one that has 3 yet. Okay, so now that we have our inequalities, we need to graph them. The one problem is this one, and this one's a problem. Why is this one a problem? Because it's not in slope-intercept form. So we have to put this in slope-intercept form. Okay, so let's go ahead and do that. I'm going to use my other purple. Okay, and I'm just going to write this problem right here. 20x plus 10y is greater than 125. And we're going to solve it for y. So we're going to subtract 20x to both sides. And since we are, what are we doing? Oh, we're trying to put in slope-intercept form. So I'm going to put that, the variable first, negative 20x plus 125. Okay, and then what are we going to do? What are we going to do? We are going to divide both sides by 10, which means you divide everything when you're trying to get into slope-intercept form, right? So y is greater than 20 divided by 10 is 2, so it's going to be negative 2x plus, that's probably going to be like 12.5. But let me just make sure. 125 divided by 10. 10 goes into 12 one time. And then we drop down the 5. 10 goes into 25 2 times. That's 20. And then we got to make a decimal, add a 0. And then 10 goes into 55 times. Yes, so 12.5. This is going to be interesting as far as graphing goes. Okay, perfect. So I think what I want to do is I want to graph this one first, because this one is going to be the most challenging one to graph. There's a couple different ways we could do this. We could just find the 12.5 and then go down to over 1, which we'll probably end up doing. If it was more complicated than this, what I would suggest is graphing that, like if the slope for whatever reason, like a different problem or you got a story problem, I would graph the y-intercept, and then I would try to figure out what that x-intercept is. And remember when we solved for x-intercept back in chapter 4? Like you find what do you always know about the x-intercept? That y equals 0. And then you solve it. And so I would, if it was more complicated than this, I would graph the y-intercept at 12.5, and then I'd figure out what the x-intercept is, and then put that point, and then just connect the dots. But I'm pretty sure that we can do this. So let's go ahead and do this one. This is going to be 12.5. So if I'm looking at this, it looks like each of these are in increments of 1. So, and then this is 13. Where's my black? Okay, so this is 12. So 10, 11, 12, 13. So 12.5 would literally be right in between those, which is right here. So this is 12.5, okay? And then from that point, we're gonna go down to and over 1. So this is a little bit more tricky because we're dealing with 0.5s. So we're at this 0.5, so we're gonna go to this 0.5, and that would be 1. And then here to that 0.5 would be 2, and then over 1. So that's a point. And let's do it again. Down, but you got to go to the 0.5, right? So that's 1, and then that's 2, and then over 1 would be right there. Oh, did you not even see that? Let me do it again. So we're at this 0.5, right? So you got to go down to the 0.5, and then down to the other 0.5, and then over 1 right there. Okay, and we'll do it again. So down to the 0.5, down to that other 0.5, and then over 1. So you're just kind of landing in between those. And then again, down 1, down 2, over 1. And then lastly, down 1, down 2, over 1. Perfect. And then what's it going to be, a solid or a dashed line? and it looks like it's a dashed line. So let's go ahead and draw that dashed line in. It's a lovely dashed line. Okay. And what's nice, what I love about this graph is, what did we say the variables were? So the x's represent the number of mowing jobs. And so here the x-axis, you label that with story problems. So this is the mowing jobs, and then the y, right? The y is the raking jobs, and so the y-axis is the raking jobs. And so and then you have a title. So this is Ed's possible earnings, okay? So whenever you're doing a graph that has to do with a story problem or application, you want to make sure that you label the x-axis and label the y-axis and put a title on it, all right? So great. So we have the hardest one out of the way, which is this one. But now it's time to go ahead and graph these other ones. So this one is y is less than or equal to 9. I mean, no, this is x. Why did I say y? Okay, x. I'm sorry. Okay, so x is right here. And 9 is right here, and x is 9 all along here. So that's going to be, this is going to be a vertical line. Okay, and it's solid. Oh, you know what? I didn't even finish that line. I needed to shade it. Oopsie daisies. Okay, well, we'll shade both of them at the same time. Okay. So there we go. There's that one. I'm going to go back here. Rewind. Okay, so here, this is y is greater than, right? So that's a shade above. So let's go ahead and shade above on that one, which is really everything here. We're shading above, shading above, shading above. All of this is shading above. I can't believe we're going to do 3. Like, the shading is just going to be out of control. I'm so excited to see what it looks like. Okay, so that's the shading for this one, which is this one. Now we need to shade this one, which is x is less than or equal to 9, which everything less than is going to be this way. Okay, so I'm actually going to do this. So it's going to be everything. I'm just going to kind of do a light shading just till, so it's everything kind of this way, right? Until I figure out what the other one is. Okay, and then this one, y is less than or equal to 7. So y is here, the y-axis, and then 7 is 6, 7 is here. And so it's going to be a horizontal line. And it's solid, right? So just trying to get it right, just right. Oh shoot, it moved. Okay. That is that one. Okay, and it's less than, so that means it's going to be everything below. So exciting. And there we have it. Okay, so where all 3 of these collide is in this region right in here. So this is where the solution set is. Really just anything in this region right here. This is where all the 3 shading overlap. All right, so cool. Any ordered pair. So really, any combination in here would work. The only key thing to this is that okay, you heard me say any combination, but what you have to understand is when we're looking in here, there's whole numbers, but then there's also like decimals, right? So like something like right here. Like that is, okay, this is 7. That's like 7.5 and 6. Well, you can't do 7.5 mowing jobs, right? So like your mowing jobs have to be actual whole numbers, like 6, 7, 8, right? Or your raking jobs have to be like a total job. So for this one, they have to be ordered, they have to be whole numbers, which means they have to be where these these lines intersect. So any of the possibilities, okay, you could have nothing on the dash line, right? However, you could have anything here, or you could have anything on this solid line or this solid line, okay? But really anything in that region, that solid line would work. So all we need to do is list two possible combinations, right? So one combination could just be, use purple. This one right here, this could be one that would work. And that would be 8. I love it when it's labeled because it literally, you just say what it is. So this is 8 mowing jobs and 5 raking jobs. So that's one possible solution is 8, 5, that ordered pair, which represents 8 mowing jobs and 5 raking jobs. All right, and what's another one? So another one, there's so many options, right? But I think I'm gonna pick the one right here where they both kind of like connect. That's kind of fun, right? So what's that? That's 9 mowing jobs and 7 raking jobs. So that's 9, 7, which would be 9 mowing jobs and 7 raking jobs. Perfect. That is it for that example. That was awesome. We did 3. I've never done a set of 3 with any students before, so this is exciting. So hopefully that made sense. So if not, we're gonna go ahead and practice this again with another example of an application. You know what, I'm gonna give you a chance to try to do this one on your own, okay? So here's my friend, okay, so you have to do all of that, everything that we just did, okay? Define your terms, write your system, like draw it all out, and list 2 combinations, okay? So I'm gonna give you the chance to try it on your own, okay? If you don't feel comfortable, that's fine, then just wait and I'll start talking and we can do it together, all right? But for those that are ready, to jump into the water, I want you to go for it. So here's my friend the pause dragon. Remind you to pause your device, go ahead and work it out, and when you get done, press play and we will talk about it. All right, see you in a bit. All right, we're back. Let's see how you did. I'm so excited for you guys. All right, so check it out, example 4. It says, at her party, Alice is serving pepper jack cheese and cheddar cheese. She wants to have at least 2 pounds of each. Alice wants to spend at most $20 on cheese. Show and describe all the possible combinations of the 2 cheeses Alice could buy. List 2 possible combinations. So this little table gives us the price per pound per cheese. So pepper jack is $4 per pound. And cheddar is actually $2 per pound, all right? So first, before we write our system of inequalities, we need to define our variables. So let's go ahead and do that. So Alice is serving pepper jack cheese and cheddar cheese. Okay, so we just don't know how many pounds she's gonna have. So that's what our variables are gonna be. They're gonna represent the number of pounds that Alice is going to have. Okay, so let's go ahead and let X equal or represent the number of pounds of pepper jack. And I would really, like, if you look down here, I would really make sure, like, this is the x-axis, right? So make sure that your x is pepper jack, or else it's going to mess the whole graph up here. So x is going to represent the pounds of pepper jack. And y, and notice what's on the y-axis. It's cheddar cheese, right? So equal the number of pounds of cheddar cheese. All right, so we have our variables defined. Wonderful, wonderful. Okay, now we just need to write our inequalities. So the first one would be, what's the information? Alice is serving pepper jack cheese and cheddar cheese. She wants to have at least, so at the minimal, 2 pounds of each. Okay, we can do that. So that means for pepper jack, right, there's X, and then there's 2, and she wants at least 2 pounds of each. So that means it can be more. So X can be more, but at least means that it still can equal to, so it's X is greater than or equal to 2, at least 2 pounds of each, right? So there's gonna be at least 2 pounds of pepper jack, which means pepper jack can be more, but at a minimal 2 pounds. And then the same is true for the cheddar cheese, right? So we're gonna use Y is greater than or equal to 2. Okay, then what is the other information here? It says Alice wants to spend at most $20 on cheese. And then it says it's $4 for pepper jack and $2 a pound for cheddar, okay? So the $20 is made up of the price per pound and then how many pounds you get, right? So pepper jack is going to be $4 multiplied by the number of pounds of pepper jack, which is X, and you're gonna add that to $2 for every pound, which is number of pounds of cheddar cheese, which is Y. And at most, she wants to spend $20. So, oh, that's a key word, at most. It's super key. At most deserves to be highlighted. I'm sorry about that, at most. So at the most, $20. So this is definitely the maximum that she wants to spend, which means all of this needs to be less than 20. But at most, she is willing to spend 20, so it can equal. Okay, perfect. There we go. Hey, it's 3 inequalities again in this system. All right. Super fun. Okay, what do I notice? Oh, this one isn't in slope-intercept form. We can graph those, right? What do we have? This is going to be a vertical line, horizontal line, and then we got to put this in slope-intercept form. So I'm just going to go ahead and rewrite that over here. And then we need to solve for y, right? So subtract 4x. And since we're putting it in slope-intercept form, make sure we put the variable first, because this is our slope, and then we have y-intercept here. And then divide each individual thing by 2 because we're doing the whole slope-intercept form thing. And that's going to be, what, -2 plus 10? Ooh, that one's nicer than the last one. Perfect. Okay, we are ready to graph. I'm going to go ahead and graph this one first. Okay, we can do it. All right, so y-intercept is 10 right here. And then what, down 2 over 1? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, and that's going to be a solid line, right? We got a solid line here. Ooh. So solid line. And also notice, just like the last one, I don't think I stated this with the last one, you don't really take into consideration, right, this is the first quadrant, and then there's the second quadrant, third quadrant, and fourth quadrant. But the other quadrants involve negative numbers, and you're not going to have negative numbers when you're talking about raking jobs and mowing jobs. It's not like you're going to have 8 mowing jobs and -2 raking jobs. Like, that doesn't happen. So with certain applications, you only take into consideration the first quadrant because only positive numbers matter. And really for this one, only positive whole numbers matter, right? And that's the same thing here. We're talking about pepper jack cheese and cheddar cheese, so we're not going to have any negative pounds of pepper jack or cheddar cheese. So we don't look at any of the quadrant 2, quadrant 3, or quadrant 4. So we just focus on quadrant 1. However, with this one, you could, have you ever been to the store, like the deli, and somebody's been like, oh, can I have 1.5 pounds of, you know, meat? And so for this one, or 1 3/4 or 1 1/4 pounds, so for this, it is possible to have the decimals. You don't have to just stay with the whole numbers because you're dealing with pounds, and pounds can be in fractional amounts. So little fun facts for you. Okay, so we graph this, it's a solid line, and we need to shade. Y is less than, so that means we're gonna shade below here. Okay, we're shading below, and you know, we can just stay right in this quadrant 1 with our shading. I think I'm trying to do a good job on the shading here. Okay, there we go. That is the first one. Now we have to do the other ones. All right, so what's this one? X is greater than or equal to 2. Okay, so here's 2. Here's 2 right here. I need a color. Let's go purple. Okay, so X is greater than or equal to 2. So that's going to be a solid line right here at 2. Vertical line. And it's solid, right? Yeah. So, I don't know why I'm hesitating. Okay, here we go. There we go. Did it. Woo! All right. And X is greater than X is greater or equal to 2, so that means it's going to be on the right side. So I'm going to have everything, you know, to this side. Ooh, that was very dark, right? So everything here, right, is shaded. I was actually trying to shade it light, and that didn't work out. Okay. And then we're going to shade Y is greater than or equal to 2. So that would be when Y is 2, which is right here, which is going to be a lovely, what's it going to be? It's going to be a horizontal line here at 2. And it's solid, right? Yeah, solid. Okay. I think, oh, and it's greater than, so it's everything, oh, it's going to be this cute little triangle. So it's everything above here. So the answer, okay, green is here, and the answer is going to be everything in this region here, okay? And I'm going to make that orange a little bit more dramatic. So this is where the solution set is. Uh-oh, kind of got out. I'm going to try to get that green in there. The green is being wimpy. I need you to be stronger, green. Be a stronger highlighter for me. I guess you can kind of tell the difference, right? So, yeah, just anything in that region. And it can be any type of number, right? It can be a decimal. So let's go ahead and pick 2 combinations. So I'll pick one right here. Let's just go here. We could have 2.5 pounds of pepper jack cheese and 4 pounds of cheddar. That would be a possible. So I'll say 2, the order pair would be X would be 2.5 and 4 pounds of cheddar cheese. So Alice could buy what could she buy? Alice could buy 2.5 pounds of pepper jack and 4 pounds of cheddar. So that's one option. And a second option, you know, there's so many in here. Let's just go with this one right here. It really could be, and it could be on these lines because they're solid lines. So it could be like this one or this one too would also be, but I'll just do this one. So 3 and 3. Or Alice could buy, ooh, that's not how you spell buy, 3 pounds of pepper jack and cheddar. Okay, that's it. So if you were able to get all that right, awesome, awesome. This was a crazy problem. So know that as long as your graph looks exactly like mine, it's possible that the two combinations that you chose could be different than mine. But as long as they're in this region or on one of these solid lines, you would be good. Anything on those would be solutions. What else was I going to say? There was something, and now it's leaving me. But this was a killer problem. So if you got it all right, yoku de kimashita. You did a wonderful job, and I will see you next time.